Hi dear children, welcome to today's class. Today we are going to discuss exercise 13.1. Question number 1. Two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. So suppose this is our first cube and this is our second cube, and it is given that the volume of these two cubes, that is equal to 64 centimeter cube. So I'm going to take the length of the cube is equal to A. Length of the cube is equal to A. Then we know that the volume of a cube is equal to A cube. And it is given that this volume is equal to 64 centimeter cube. That means A cube is equal to 64. A cube is equal to 64. And this 64 we can write it as 4 cube. So we will get A cube is equal to 4 cube. That means A is equal to 4. So the length of the cube is equal to 4. Okay, so this is 4. Same measurement for the second cube also. So this is also 4. And this side, that is 4. And this side is 4. So the side of that two cubes, that is equal to 4. Now just join these two cubes. I just joined these two cubes. Then we will get one cuboid. In that cuboid, the length is equal to, this is the length, that is 4 plus 4 is equal to 8. Breadth is equal to 4 and height is equal to 4. Length is equal to 8, breadth is equal to 4 and height is equal to 4. This is the dimension of our resulting cuboid. And we need to find the surface area of the resulting cuboid. We need to find the surface area of the resulting cuboid. Surface area is equal to 2 into, what is our formula to find out the surface area of a cuboid? That is 2 into LB plus BH plus HL. 2 into LB plus BH plus HL. And this is equal to 2 into, what is length? That is 4. 4 into, length is 8. 8 into 4 plus 4 into 4 plus 4 into 8. And this we will get it as 2 into 32 plus 16 plus 32. That is equal to 2 into 80 is equal to 160 centimeter square. Since it is surface area, we will have the unit centimeter square. Now second question. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So in this figure, we have hollow hemisphere and hollow cylinder. We need to draw the figure corresponding to our question. So this is our hollow hemisphere and we have one hollow cylinder. Okay, hollow cylinder also we have. This is our hollow cylinder. Okay. And in this question it is given that the diameter of the hemisphere is 14 centimeter. The diameter of the hemisphere. This is our hemisphere and the diameter, and this length is 14 centimeter, that is given. So this is 7 centimeter. Since the diameter is 14 centimeter, radius is 7 centimeter. Okay. And one more information is given. the height of the vessel is 13 centimeter. Okay, this is the shape of our vessel. We have one hemisphere. On the top of that hemisphere, we have one hollow cylinder, and this is the shape of our vessel. The total height of the vessel is given. Total height of the vessel is given, that is 13 centimeter. Okay. Now, in this hemisphere, since the radius is 7 centimeter, this is also the radius. Okay. This is also the radius, and that is also 7 centimeter. Okay. In hemisphere, it is given that the diameter is 14 centimeter. Then we know that the radius is equal to 7 centimeter. Since this portion is 7 centimeter, then this height portion, that is also the radius, and it is 7 centimeter. That means up to this, the length is 7 centimeter and the total height is 13 centimeter. Then what will be the height of our cylinder? Height of our cylinder, okay, the height of our cylinder, that is the height of our vessel minus the radius of the hemisphere. Okay, height of the cylinder, that is height of the cylinder, that is equal to height of the vessel. What is the height of the vessel? That is 13 minus radius of the hemisphere. 13 minus 7. What is 13 minus 7? That we will get it as 6. So the height of the cylinder, that is equal to 6 centimeter. Okay. So this is 6 centimeter. Since this cylinder is on the top of this hemisphere, the radius of that cylinder is same as the radius of the hemisphere. Radius of the cylinder is equal to radius of the hemisphere, and that is equal to 7 centimeter. And what is the inner surface area of hollow hemisphere? What is the inner surface area of hollow hemisphere? That we know, that is 2 pi r square. Surface area of hollow hemisphere, that is equal to 2 pi r square. And the inner surface area of hollow cylinder, surface area of hollow cylinder, that is equal to 2 pi r h. 2 pi r h. Here the radius of the hemisphere and the radius of the cylinder, that is equal. So this is equal to, what we will get, 2 into pi into, what is radius, 7 square. 2 into pi into 7 square, that is 98 pi. This is equal to 98 pi centimeter square. And this is equal to 2 into pi into radius same, so 7 into height 6. And that is equal to 84 pi centimeter square. 84 pi centimeter square. Actually, we need to find out the inner surface area of the vessel. We need to find out the inner surface area of the vessel. In that vessel, we have hemisphere and cylinder. That's why we took the surface area of hemisphere and cylinder. This vessel surface area is actually equal to, what is vessel surface area? Surface area of the vessel, that is equal to surface area of hollow hemisphere plus surface area of hemisphere plus surface area of cylinder. Surface area of hemisphere plus surface area of cylinder, that is equal to 98 pi plus 84 pi. 98 pi plus 84 pi, that is equal to 182 pi. In this question, it is not given that pi is equal to 3.14. Then we will take pi is equal to 22 by 7. So this is equal to 182 into 22 by 7. That we will get it as 572 centimeter square. So the inner surface area of our vessel, that is equal to 572 centimeter square. Third question. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. So here also we have combination of figures. In this question, we have one hemisphere and a cone. We have hemisphere and cone. So, this is our hemisphere. And above this hemisphere, we have one cone. This is the shape of our toy. And it is given that the radius of the hemisphere, okay, the radius of the hemisphere and the radius of the cone, they are equal, and that radius is equal to 3.5. It is given in the question. Okay, 3.5. And the total height of the toy is given, that is 15.5. The total height of the toy. Okay, the total height, that is 15.5. Okay, actually the total height of the toy, that is the height of the cone plus radius of the hemisphere. Total height of the toy is equal to height of the cone plus radius of the hemisphere. So, what we will get? The radius of the height of the cone is equal to height of the cone. Height of the cone is equal to height of the toy minus radius of the hemisphere. Height of the toy minus radius of the hemisphere will give the height of the cone, and that is equal to 15.5 minus 3.5. It is equal to 12 centimeter. So the height of the cone, that is equal to 12 centimeter. Radius of the cone is equal to 3.5 centimeter, and the radius of the hemisphere is equal to 3.5 centimeter. Now we need to find out the total surface area of the toy. We need to find out the total surface area of the toy. And we know that the curved surface area of the cone is equal to, what is the curved surface area of the cone? Curved surface area, that we will denote it by CSA. Curved surface area of cone is equal to pi RL. Curved surface area of cone is equal to pi RL. That L is the slant height of the cone. Okay, this length. Okay, this is our L. We need to find out the L to get the curved surface area of the cone. Okay, so we have one relationship between this L, R and H, that is L is equal to square root of R square plus H square. L is equal to square root of R square plus H square, and that is equal to square root of, what is the radius of the cone? 3.5 all square plus height of the cone 12 square. And this is equal to square root of 12.25 plus 144, and it is equal to square root of 156.25 is equal to 12.5 centimeter. So we will get the slant height of the cone is equal to 12.5 centimeter. Now we will substitute that value. This is equal to pi into 3.5 into 12.5. It is equal to 3.5 into 12.5 into pi, that is our CSA of cone. Now we need to take the curved surface area of hemisphere also. So total surface area of the toy is equal to CSA of curved surface area of the hemisphere plus CSA of the cone. Curved surface area of the hemisphere plus CSA of the cone, that is equal to curved surface area of the hemisphere is 2 pi r square plus pi r l. Pi is common, so we will get 2r square 2r square plus rl, and r is also common, we can take it outside, so pi r into 2r plus l we will get, pi r into 2r plus l we will get, and that is equal to pi is 22/7 and r is 3.5 into 2 into 3.5 plus slant height, that is 12.5. Okay, after all the calculations you will get it as 214.5 centimeter square. So the total surface area of the toy is equal to 214.5 centimeter square. Fourth question. A cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So this is our cubical block and we have one hemisphere on this cubical block, and first we need to find out the greatest diameter of this hemisphere. The greatest diameter of that hemisphere actually is equal to the side of the cubical block. Okay, diameter of the hemisphere is equal to side of the cubical block, and this is equal to, what is the side of the cubical block? It is given that a cubical block of side 7 centimeter. Side of the cubical block is given in our question, that is 7 centimeter. So the diameter of the hemisphere is equal to 7 centimeter. Then the radius of the hemisphere is equal to 7/2 centimeter. Now we need to find out the total surface area of the solid. Now just look at the figure. The total surface area of the solid is equal to the total surface area of the cubical block plus the curved surface area of the hemisphere. Okay, the total surface area of the cubical block plus curved surface area of the hemisphere. And but this shaded portion, this will come in the total surface area of the cubical block, but we don't want to take that portion. Okay, so we need to exclude this shaded portion from this surface area. How can we do that? What is that shaded portion? That shaded portion is actually the base area of the hemisphere. So the total surface area of the solid is actually the total surface area of the cubical block plus the curved surface area of the hemisphere minus the base area of the hemisphere. We need to minus this base area because this shaded portion that we can't see actually. Okay, the shaded portion we can't see actually, but if we took the total surface area of the cubical block, then the shaded portion is also included, so we need to exclude that shaded portion. That's why we are minusing that base area. Okay, so total surface area of the solid, surface area of the solid it is equal to total surface area, TSA, total surface area of the cubical block, plus curved surface area of the hemisphere, CSA of the hemisphere, minus base area of the hemisphere, and this is equal to the total surface area of the cubical block, that is 6a square. Total surface area of the cubical block, that is 6a square, plus CSA of hemisphere, curved surface area of the hemisphere, 2 pi r square, minus base area of the hemisphere, the base of the hemisphere in the shape of a circle, so that area is pi r square. So this we will get it as 6 into 7 square, 2 pi r square minus pi r square, that is pi r square. So this is 6 into 7 square, that is actually 294, plus pi is 22 by 7 into the value of r, that is 7 by 2 all square, and this is equal to 332.5 centimeter square. 332.5 centimeter square. So the surface area of the solid is equal to 332.5 centimeter square. Now fifth question. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So in this case also we have one cubical wooden block. We have one cubical wooden block, and what we are doing here, we are going to cut one hemispherical depression. We are going to cut one hemispherical depression. Okay, we are going to cut one hemispherical depression from here. Okay, and it is given that the diameter of the hemispherical depression is equal to the edge of the cube. Diameter of the hemispherical depression is equal to edge of the cube, that is given. Diameter is equal to L, then radius is equal to L by 2. Diameter is equal to L, then radius is equal to L by 2, and the length of the edge of the cube, length of the edge of the cube, it is given that the diameter of the hemispherical depression and the length of the edge of the cube, they are equal in length. So length of the edge of the cube is equal to diameter of the hemispherical depression, that diameter is L. So the length of the edge of the cube, that is equal to L. Now the surface area of the remaining solid we need to find. The surface area of the remaining solid, surface area of the remaining solid, okay, that is equal to curved surface area of the hemispherical depression. So, okay, surface area of the remaining solid means this portion is not there. Okay, this portion is not there. Then the remaining solid, here the shape, that is the curved, that is the portion of our hemisphere. So we need to take the curved surface area of our hemisphere. Then we need to take the total surface area of the cubical block. If we took the total surface area of the cubical block, then this portion will comes in that. We need to exclude that portion, that is the base area of the hemisphere we need to exclude. So the surface area of the remaining solid is equal to curved surface area of the hemisphere plus total surface area of the cubical block, TSA of the cubical block, minus base area of the hemisphere. Base area of the hemisphere. And this is equal to CSA of the hemisphere, that is 2 pi r square, and the base area, that is pi r square, plus TSA of the cubical block, that is 6a square, and here the value of a, that is L. So 2 pi r square minus pi r square is pi r square plus 6a square we will have. Pi r square plus 6a square we will have. Now just substitute the values. R is L by 2. So pi into L by 2 all square plus 6 into L square. Pi into L by 2 all square plus 6 into L square. And this we will get it as L square by 4 into pi plus 24. L square by 4 into pi plus 24. So the surface area of the remaining solid, that is L square by 4 into pi plus 24.